Welcome to this demonstration of the FLUIDOS Privacy and Security workflow. Today we'll show how the system enforces secure access to resources using verifiable presentation. The demo setup consists of two FLUIDOS nodes, a consumer and a producer, as shown in the image above. Both nodes feature their own privacy and security manager to autonomously handle security, identity, and distributed access to the DLT. The producer node also includes the rear API for resource acquisition, which is secured. On the terminal to the left, we have the workflow menu for the demo, showing the steps we will follow in sequence. On the right, we have the terminals for each FLUIDOS node and one for the rear protocol interactions. The first part of the demo is the enrollment section and DID generation. Let's start by generating a DID, decentralized identifier, for our consumer node. This will be the identity we'll use throughout the demo. Next, we'll generate a producer DID using option 2. The producer needs its own DID to participate in the workflow. Now that we have both DIDs set up, let's try to access the producer's flavors without proper authentication. We'll select option 5 to list flavors. As you can see, we get an error message saying we need to generate a verifiable presentation first. This demonstrates the security mechanism in action. We cannot access protected resources without proper credentials. Let's fix this by following the correct sequence. First, we'll request a consumer credential from the issuer using option 3. Now that we have our credential, we can generate a verifiable presentation, what contains a subset of the verifiable credential, revealing only the attributes needed for this process using option 4. With our VP ready, let's try listing the flavors again with option 5. This time it works. We can see the available flavors and access the rear methods of the producer because we presented a valid VP token that proves our identity and permissions. The flavor 001 will be selected for reservation. Let's continue with the reservation and purchase process. First, we'll create a reservation for our selected flavor using option 6. This step requires our VP token again to authenticate the request. The system creates a reservation for the flavor we selected. Next, we'll initiate the purchase process with option 7. This step is interesting because it starts the contract signing process. When we perform the purchase, first, a contract is generated for the reservation. Then the producer automatically signs the contract using a JWT DID signature. Now it's the consumer's turn to sign the contract using option 8. The consumer reviews and signs the contract that was previously signed by the producer. This creates a dual-signed contract that represents the agreement between both parties. Finally, we can verify both signatures on the contract using option 9. This step ensures that both the producer and consumer have properly signed the contract and that the signatures are valid. The verification chain is valid, and both signatures in the contract are correct, as we can see. For more information about the FLUIDOS project and its security framework, please visit our documentation or contact the development team. Thank you for watching this technical demonstration.